Hey, welcome back to another edition of JavaScript Funct-on-ions. This is day 12 of our peeling away of the understanding of how functions work in JavaScript in many different ways. I like to call them multiple personalities. And we've seen quite a bit so far in our journey of trying to make it through 30 days of finding all the different ways that functions can work in JavaScript. And the yesterday's on day 11, we looked at a recursion, and what we did was we just went through this recursive process of building up a character string of a letter. So our example was G, and what we looked at mainly was the fact that with using recursion, where the function calls itself until it gets to a certain base, then the code can be more understandable, I think more readable than as opposed to for loops where you have more code you have to mentally understand. And the same with a while loop. So I wanted to come back to this again because I still want to wrap my head around this whole understanding of how a recursive process works. And so one of the most identified functions that is used to understand recursion is the factorial. And so the factorial will build upon itself and continue to build upon itself until it gets to the input, the argument that is input into the parameter is at the base case. So, for example, like what we have here to show you, and we'll step through it here, and we'll look at it in two separate processes. And this one right here, so in this function, we are passing in an argument to this parameter n. And so you can see over here that this whole factorial function in the global frame is holding the whole function itself at this point in time. As you can see with this red line arrow, it explicitly says that this next line to execute. So nothing has executed. We haven't previously executed anything. All we've done is gone through a compilation phase. We've compiled JavaScript, not we. JavaScript, the engine, has compiled this function and has stored the whole function into memory. And now we're about to go into this factorial and call with passing in the argument 10. And so when we're going to step forward here, and you can see that there's going to be 41 steps that are going to get us to the result that we need. So now when we go in here, it's going to look at what we call a base case. And the important thing with recursion is you need to have a base case, because if there is not a base case, then it's never going to end. So with ours being is that we're going to always check and see if 10 is less than 0. And if that is the case, then we're just going to return. So at this point in time, we have in our call stack, we've got an execution context where we've passed in n. So n is the number 10. And we're going to go forward. And so it didn't hit the base case, and it didn't hit 1. So we're now into this else, where we're now going to return 10 times, and then factorial is going to call itself with 10 minus 1. Now, in functions, returning will actually return you to where you were called. But with this particular instance, you'll see is that won't be the case, because we're making another call to a function which so happens to be itself. And so if we step forward here, we're going to see now is that we have called n times factorial 10 minus 1, which now gives us the factorial with n being 9. Now, so we haven't returned out of anything, so we don't have a returned value at this point. All we have is we have a new execution context where we're actually still in this factorial, but we have a now n being the value of 9, and we're going to step back through the same process. Let's just go through. So we're going to now, if you get the understanding of it here, is that we're again back at this case to where n, which is the value 9, is going to be multiplied by factorial n minus 1, so it'll be 9 minus 1. So when we call factorial, it's going to be passing in the argument 9 into 8 into n. So now when we go forward, we have a new execution context, factorial, and that is going to be 8 being passed in. Now, so we're going to go through this a little bit quicker because you're going to start to see how it works. But the one thing about this is that you'll see that it continues to add to the call stack, because we can't return out of this because it's continually calling itself. So as long as there's a function that's inside of another function that's being called, is that all it's going to do is it's going to call itself, and it's going to call that function, and then once it gets the return value, it's going to return that value and go back and go to where it was called. So you'll see we're still inside of the factorial function, so it's going to continually return back to itself. So let's just keep forward here, and we're going to see that it's just going to continue to build. And this is something where we're going to finally get to a point where we're going to hit a base case. And we can just scroll down a little bit here and watch it continue to go. And finally we're going to get to, so now we have 1. Okay, so now let's go here. And now n equals 1. Let's see what happens. So we went back and we're here and we're returning n. So there's no longer hitting this else, so it's no longer calling itself. So now we're returning n. But what we're going to see here is that we're actually returning a value, because now it's going to return. But what's going to happen is that it's going to return to the previous place to where it was called, and that's still inside of this factorial. So now what's going to happen is that the call stack is going to unwind, but as you'll see here is that it still has a reference to the end when it is actually returned back to where it was called. So if we watch this now, this is that we have 1, and if we step again, is that we have a return value of 2. So now if we step again, is that we have 2 plus 1, and now we have 6, because 2 plus 1 was 3, and now we have 3 plus 3, which is 6. So now if we step again, we're now going to see that we have 24. And let me go back because I want to make sure that I did something wrong. I did not explain that right. I was adding. We are multiplying here. So we got the n. If this was plus, then it would be a different case, but we're actually multiplying. So 2 times 1 when we step forward is going to be 2. Now the next time is going to be 3 times 2, which is going to return 6. So I think you'll start to see the process here is now we're going to return the 6. So it's going to be 4 times 6, which is 24. And then so it's going to keep returning that value to the previous place that it was called. And that it was inside of the factorial function calling itself. So now you're starting to see that it's unwinding the stack, returning to the previous place that it was called. So each time it's taking that previous value. So now it's going to take 5,000. Let's just double check this. 5,040 times. Let's see if this gives us. I got bad math. Let's hope that it's 40,320. There you go. So now this time we're going to take this 40,320 and multiply it by 9. So now you'll start to see that we're just unwinding the stack, and we're able to multiply because it's remembering the previous place that it was called from. And so now we have met the first call, which was the call of the argument 10 being passed in to the factorial function, and we get our returned value. So that's one of that gives you a general idea of the recursive process, is that you always have to make sure that there's a base case. So you have to make sure that there's a base, otherwise you're going to get to the point to where it's not going to end, and you're going to get a max exceeded. Whatever I can't remember what it is, but in general terms, as most people will know of it as being Stack Overflow. So you saw the stack grow. You know, if we continue to go back, you know what, it's growing, and then if we, you know what, then we can unwind it. But if we don't have a base case to where it knows when to stop, then then we're just going to continue to go and go and go and go. So, but each time here is that it's multiplying the n, which is currently 8. Well, it was currently 8, which gave us the return value. So now the next time that it's called, it's going to call the 40,320 and multiply it by 9. So there you go. So that's the one thing about recursion is that there's, I think that for me, I've come to find out that this is easier to mentally comprehend, opposed to having to go through a for loop, to where I'm trying to, you know, figure out and remember, okay, I got to create this, you know, this variable, and then I have to, you know, create a check, and then increment it. You'll see, I mean, you could pretty much take this whole factorial recursion function and pretty much identify all of the aspects of a for loop or a while loop. But again, you know what, to me, is that as long as you understand that there's a base case, and then whatever it is that you're trying to accomplish with the recursive process, is that it won't go out of bounds based upon whatever the return value is for the base case. I also wanted to just take a look too, is that if you're playing around with this same process in the dev tools, is that you could take this and you could set some breakpoints. So I've set one in the else if, and also when we return n times the factorial of itself. And then I got a breakpoint on the factorial on line 13. And what we can do is over here is that we can watch the call stack grow as we continue to go through this process. So if I start this and we hit the breakpoint here on line 13, is that this is when we're actually doing our first call, and we've got the argument 10, which we're going to pass in to n, which will then be so our initial process of the execution context that's going to be created, n is going to be in that local memory, which is going to be 10. And so now you'll see, watch, as we just passed in 10, and now so n is going to be 10 as we go through this process. So, you know, you can kind of just, if you need to, hover over all the all the n's, I'm sorry. And then, so you can continue to watch as the n number decreases, because we're taking the number n. So when we call factorial, we're taking the number and then we're decreasing it by 1. But each time that it's calling itself, it's adding a new execution context on the call stack. So we'll get n to continually decrease, and so now n is at 0. So as long as n is not less than 0, then we're going to be okay. If we never had this if, then it would continue to go -1, -2, -3, on and on and on. So now that we've hit this, we're going to now start to see that we're just unwinding. Now we don't see the actual value as it's happening, as we did in over here. But at least you can watch this call stack as it continues and then is done. So whether you're working in the developer tools or whether you want to use this Python tutor, either of them will really give you an idea so you can step through the process of watching to see how this works, and get a much better idea. Actually, let's do something here. Let me just see something. I don't know if that's gonna do anything for us. You know what we can do? Let's just step through this real quick. Let's do something here. Yeah. Let's delete this. All right. Yeah. One of the other parts of the Chrome Dev Tools is you actually can watch. And so with the watch is that you can actually just put in a value that you want to see what happens. So did I put that in right? Okay. So what we're going to do is we're going to watch n and see what the value is. So let's go ahead and just run this here. Okay. So now we're seeing that n is 10. So let's continue. And so from the watch, if you wanted to, you could watch and see what the value is, or what the value is at that particular time in the call stack. So once we're here, we're now at 0. And so we know based upon line 2 is that it checks to make sure that if n is less than 0, it will just return. So it doesn't. But so you'll start to see now that n just continually just goes back up. And then now it's at its initial call value, which was passing in the argument 10. And then we're done. So that really show you that, you know, the recursive process is the function calling itself and then being able to decrement itself or increment itself, as long as it does not go past whatever your base case is when you're actually running the recursive process. So I hope that's another good, I don't know if it's better. It was a better understanding for me of the recursive process, and I hope it can help you as well to identify what is actually happening during this process. And both of these tools you can use to just watch and see what happens as you continue to step through the program. So this is day 12, and I will see you back here the next time if you want to join me. And we're going to get into some of the processes of knowing a little more about this and how how this is actually determined based upon how you call it. So we're going to get a little bit into that and see just exactly another aspect of functions in JavaScript, and as I like to call them, the multiple personalities. So I'll see you then.